Hello everyone, welcome to Chemazon-Complete Chemistry. So this is question 22 of the JAM 2022 chemistry paper. This we are going to solve, which is based on the stability of the borane adducts. We'll see what is borane adducts. Okay, these are the examples of the borane adducts that is given. Okay, and we have to find out the order of their stability. Okay, so now let us first understand how a borane adduct is formed and what exactly is a borane adduct. Borane, what is borane? Borane is BH3. Okay, borane adduct means there is this borane compound. Borane is BH3. Okay, borane has an empty vacant p orbital or empty p orbital, and there is a ligand, okay, or electron rich species that will donate electrons in the vacant p orbital of boron. So what happens is a coordinate complex is formed. Okay, a coordinate complex is formed between ligand and borane. This is called as the adduct, borane adduct. Okay, now how does this reaction take place and what is the role of this ligand and borane? This is a simple Lewis acid base reaction. Okay, Lewis acid base reaction. In all the complexes you can see, okay, first let us understand what is Lewis acid and Lewis base. So I had told you to remember a mnemonic, that is late. What is late? Late is Lewis acid take electrons. Okay, Lewis acid takes electrons, and what is Lewis base? Lewis base is opposite of this. It is donating electrons. It donates electrons. Okay, so now I'll identify which is Lewis acid and which is Lewis base. This is accepting electrons, so this is what? This is a Lewis acid. Lewis acid take electrons, and ligand is Lewis base. Okay, and the stability, what does the stability of this adduct depend on? The stability is directly proportional to strength of the boron and the ligand bond. Boron and the ligand bond. Okay, stronger the bond, more will be the stability. Now how do we find out whether which bond will be stronger and which bond will be weaker? So bond strength will eventually depend on, here you can see the Lewis acid is same, what is changing is the ligand. Okay, so bond strength will directly proportional to the electron donating capacity. It will depend on the electron donating tendency of ligand. Electron donating tendency of ligand. Okay, let me draw all the four ligands that they've given, or we can say Lewis base that they've given. One is PF3. Okay, phosphorus has a lone pair that can be donated. Then we have NMe3. Me is methyl. Okay, trimethylamine. Nitrogen has a lone pair that can be donated. Then there is carbonyl. Okay, carbon has a lone pair that can be donated. Then we have OMe2, dimethyl ether. Okay, oxygen has the lone pair that can be donated. Here carbon can donate, nitrogen can donate, and phosphorus can donate. Now the one which will be most electron rich, that complex will be most stable. Now if you see here, methyl group is what? It donates electrons via plus I inductive effect. Okay, it donates via plus I inductive effect. So the complex formed by trimethylamine and borane will be the most stable. Okay, we have to arrange in which order? Increasing order. Okay, so BH3 NMe3, this is going to be most stable. Okay, so which options are there? Okay, it is an increasing order. So you can see here there is BH3 NMe3 and this. B is incorrect, C is incorrect. Now between A and D we have to decide. Okay, so this was the first stable complex. Now second, after nitrogen, if you see, okay, directly if you see the atoms that are attached, phosphorus, carbon and oxygen, you might think that phosphorus is least electronegative So it is a better electron donor, but that is not correct. Why? Because here you can see there are these 3 electron withdrawing fluorine atoms. Okay, there are 3 electron withdrawing fluorine atoms. So this is what? This is least electron rich. Least electron rich. Okay, the complex formed by PF3 is going to be least stable. So BH3, PF3 is the least stable. Then now you compare between this dimethyl ether and carbon monoxide. Now here again you can see that you might think that carbon is having less electronegativity, so it should be a better electron donor. No. Why? Because here you can see there are these 2 methyl groups that can donate electron density via plus I inductive effect, also via hyperconjugation. Okay, they donate by inductive effect as well as hyperconjugation. So the next stable complex after BH3 and Me3 is which one? BH3 OMe twice. Okay, dimethyl ether, and in between we have CO. Okay, so this is the stability order: PF3 less than CO, PF3 less than CO, less than OMe2, less than NMe3. So which is the correct answer? Option D.